This lecture is going to cover the area computations, and we're going to use the computation of geometric figures, the trapezoid rule, the Simpson's third rule, coordinates, and the double meridian distance method. So let's get started. Area of a rectangle is basically the length times width. We know that. The area of a trapezoid is important because a lot of these geometric figures are broken down, and we're looking basically for the area of a parcel or project. And a trapezoid is basically you're adding the two bases, B and A, divide it by 2, and then multiplying it by the height. Now the area of a triangle we're breaking down is basically base times height divided by 2. Also the area of a triangle you can use because of, you can see that you're breaking it down into a right triangle. We can bring in trigonometry and solve it. So it's basically the base times the side slope, sine of C, this angle here, divided by 2. We'll be using this later in this class. Also, the area of a triangle, this is the Heron's rule, basically says that S is equal to ABC divided by 2, and then you can see the equation here. Now, we'll be using these throughout the class to figure out area of a parcel of land. We also have sector and segment that we have to worry about. For example, if you're on a roadway or if your parcel has a curve, then we have to look at the area of curves inside of our project. So we look at segments and sectors. Segments are basically looking at the chord that's connecting the circle on a straight line, whereas a sector is something that has an angle that we'll be working in. Now, excuse me. The area of a circle is basically pi r squared, but here's the thing. We know that 360 degrees is equal to 2 pi. So we've got radians in here, and if you remember your highway drafting or your highway class, then we looked at radians when we looked at the intersecting angle of a horizontal curve. The area of a sector is going to be the angle, you can see theta, divided by 2 pi times pi r squared. So basically, it's taking into account the radians. So if you reduce it down, then it's basically the angle of the sector divided by 2 times r squared. Now, you can rewrite it. So here's the equations in, oh, that should have been a theta. Sorry, that should have been a theta. Theta is either in radians or it's in degrees. All right. Now, when we're talking about a segment, here's a segment. We have a sector and then it's bisected by a chord. And we want to know the area that is from that line to the arc. Okay? So we have the area of a segment is basically taking the sector minus the triangle that's represented here. Okay? So that's how we figure out our segment area. So the area of a segment is basically theta minus sine of theta over 2 times r squared. You can also, that's in radians, and you can also do it in degrees. Now you also have arc length, okay? So let me go back to this one more time. When we're doing this, it's this part of the equation that gets rebuilt is because of the area of the triangle. We've got the area of the whole sector, minus the area of the triangle that's added into it. And then you have your arc length. Again, theta is in radians, and then theta is in degrees. So I'm not going to go over the breakdown equations, but you have them here as you work forward on the homework. Now, one of the methods to calculate area, and this was done in basic survey, is the coordinate method. That means we have a traverse that we went out there, A, B, C, D, E, F, back to A, and we know the X, Y coordinates of each one of these points. So we're going to use that to solve for the area. Now, you have to have a closed traverse. That means we've already balanced the angles interior. They close to a perfect theoretical polygon. And we have the adjusted latitudes and departures that basically say that it's completely closed at the end. Now, basically, the area is equals 1/2 m minus n, meaning your x's and your y's. And if you remember, this is how we looked at it in our basic survey class. So what it's saying is the x, y, and coordinates, if I write it out, the corner A, B, C, D, E, F back to A, if it's linear form, you'll see it like this. x1 times y2, x2 times y1, but I prefer to see it this way. You'll have a lot of textbooks that write it this way. I prefer to see it this way. So I write my coordinates, northings and eastings, starting from 1, 2, 3, 4, back to 1 per se. Whatever you start on, you have to end on. It's basically making a closed loop. So take a look at the red. It's going easting 1, northing 2, multiply those together. So there's a left-hand product and a right-hand product. So in the blues, it's northing 1, easting 2, and you write it over here. This is really simple to do in Excel, and that's what I recommend for you to do. And you keep crisscrossing these. Now, once you get them done, you'll write it northing 1, 2, 3, 4, back to 1. It has to close on itself, but you'll only have the number of points or corners you have in your products. You'll add up all of the left-hand side, and you'll add up the right-hand side. That's what it means by sum of LH and sum of RH. When you add these up, you're going to subtract them. Now, one side might be bigger than the other, so it's going to give you a negative value. So what we do is we say, okay, the sum of the left-hand side minus the sum of the right-hand side, it's an absolute value, and then multiply it by 1/2 or 0.5, and that'll give the area of this polygon. Now, the way that it works is, if you look at the area in this polygon, it's basically breaking it down into trapezoids, and we know how to solve for trapezoids. So if you look at capital F, capital A, so it's going F, A, little a, back to F. What did I just create in that blue? A very large trapezoid. And then the other one is capital A, capital B, little a. So that is our total area, right? But our trapezoid is this. Now I have to subtract out all the little trapezoids in there. So, and that's what this problem is showing you. Now, to do the little trapezoids inside here is we're looking at x, and these could be thought of as subscripts, x of d plus x of c times y sub d minus y sub a, all multiplied by 0.2, or by 1/2. These are showing you the smaller trapezoids that you're now going to subtract out of it. All right? So if you want, take a look at that and you can see how it breaks down, but I'm not going to go through all of the proof of how this works in this class. Now, here's an example of basically showing you, okay, I need the area of the hatch, okay? And I've got the area, so we have a trapezoid, we have a polygon, but it has an arc or a sector subtracted out of it. So we have to take this into bite-sized pieces. First thing we're going to do is we're going to find the area of 1, 2, 3, 4, 5, 6, and then we're going to subtract out the segment, okay? We know our coordinates are northing and eastings on this. So I'm going to pause here, and then we're going to go over this example.